Hello everyone, welcome to my presentation. Today I am going to present a research paper. The title of this research paper is A Comprehensive Machine Learning Framework for Evaluating Agility of a Software Development Organization. This research paper is published on August 2025 and the author of this research paper is Suman De. The journal was published at IEEE Engineering Management Review. This is the agenda of this research paper I'm going to present today. So we will walk through first introduction, then primary goals and background, description of work and problem statement, proposed methodology including results and discussions, business relevance, conclusion, and future work. Introduction. Planning a software development project in any organization introduces the prospect of the following sequence steps: adopting a model for software development such as Scrum, Kanban, Scrumban, and so on. The synergy of manufacturing methods has given rise to Agile and has seen a massive adoption of process, is widely used by most software development organizations. Also, Scrum has emerged as the predominant strategy for large-scale development organizations as Agile methodologies have progressed. Scrum's events facilitate the development team's focus on individuals and interactions in creating a functional software version. To mitigate the risk to a system, it is advisable to integrate the techniques with Scrum events to enhance the development of the system and software product discussed in this article. So, the primary goals and background we are now going through. Back in the software industry, there was the measure of the work based on hours or person days. But Agile doesn't support this. So this paper showed the complex measurement of work should not depend on time. It should depend on the complexity of the story point. And the previous sprint data using ML model, KNN decision tree, which can tell which sprint is success and which organization is using Agile. This researcher used synthetic dataset to show the organization how vary is the data each organizations with the percentage of accuracy. So this study also examined a new approach to combining framework and using it to measure and predict organizational efficiency using k-nearest neighbor. This article also examines scenarios that illustrate how velocity-driven planning can assist a software organization. A synthetic dataset to demonstrate how current datasets can assist a Scrum Master, which I already told before. And this results in higher accuracy as seen for organization 2 that they showed that with 87% accuracy and 95% for organization 3. Description of work. So the author divided the whole structure of the work in some segment. So section 1, he said that the hypothesis here states that KNN and decision trees can be used in a story point based estimate strategy to significantly improve the accuracy and dependability of sprint planning and project success. In section 2, it presents the related work. In section 3, it gives a short explanation of story point based development. Section 4, it describes the proposed methodology of combining this framework with ML algorithms. Also, this section 6 covers an industry perspective. Section 7 finally concludes the section. The problem of this problem statement of this research paper, it was back in the industry. The problem arises is like traditional estimation. Management still wants hour person day, which is complex for the Agile system. The velocity misuse. They use velocity to comparing the team, which in real management do this, but velocity doesn't compare the teams. It also human bias. Sprint planning depends on predicting, but when there is new team develops, the velocity prediction of velocity will be tougher. So based on to resolve these issues, the researchers suggest machine learning as a solution of this problem in this paper. Literature review. Back in the time, previous researchers worked on few things such as effort estimation using ML, risk prediction, task classification, text analysis using natural language process. So the limitations of those things are now they are effort based, lack of dynamic complexity, Scrum value never used as organization maturity. This paper worked on these limitations. Story point based development. So researchers said that the development process does not follow a develop first, validate later approach. Instead, it emphasizes continuous feedback from the client through minor iterations. Each incremental iteration prioritizes value creation for the end user by offering feature and make total sense to a consumer. The authors said the story point actually based on complexity of work, risk, and uncertainty. Where the velocity depends on the number of total completed story point and number of sprint. The challenges they faces it requires new team, big project, multiple team, hard to predict velocity. Proposed methodology. The author proposed some methodology to resolve these issues. So he input the features, number of stories, BLIs, team size, planned points, completed points, priority, sprint results, which shows the rate of success or failure. And he used here algorithm decision tree, k nearest neighbors, and random forest. Decision tree. A decision tree is generated as shown in figure. We can see in the right side of the figure based on training and test dataset provided to decided on velocity and comparison for the test database. And it depends on some things, each internal node, test, and attribute. Each branch corresponds to an attribute value. Each leaf node assigns a classification. So basically, decision tree actually works based on questions like which plant point is huge and what is the team strength, is the team strength enough or not, and does completed point match works or not. At the end it will measure the sprint is successful or failed. So in KNN, we can see that it is classified that the KNN indicates how your previous sprint worked, and it will search the nearest sprint using Euclidean distance, and it will measure the success or failure rate. This technique involves the development of software that aims to forecast and success or failure of a sprint for a given set of test data. The KNN classification rule is used to determine the majority category level of its k nearest training samples. So now we have to focus on some areas on this research paper. This datasets, as I said, the author used synthetic dataset. So they divided it through some process, and they used some algorithm. The algorithm one tells the function predict classification takes training data, a test instance, and a parameter for the number of neighbors. Algorithm 2, the calculate Euclidean distance function mentioned above determines the Euclidean distance between the two data points. Algorithm 3, the get neighbor function identifies the closest neighbor of the test instance by calculating the Euclidean distance between the test instance and every instance in the training dataset. So this is the result and discussion of the three organizations comparatively. The author shows that in organization 1, the accuracy is very poor, which is 39%. Estimation is inconsistent, and agile maturity is less. Organization 2 comparatively is higher performative than organization 1, which accuracy is 87%, and it practices Scrum very well. In organization 3, our accuracy showed that 95%, highly mature agile organization, and confusion matrix is higher. Business relevance. The present study improves the understanding of adoption by offering insights into the calculation of velocity and prediction of sprint success or failure based on specific feature values. As we know, Scrum already widely used SAP, Google, Netflix, but it uses in the organization in a wrong way. This framework reduces human bias, data-driven sprint planning, better roadmap forecasting, and improve OKR. So the conclusion. So after all this study, we can say the research paper actually focused on time-based. That time-based estimation is now outdated. It depends on story point and ML, so it will make organization more reliable. Measure organization agility using velocity. Gap of this research paper, we can say no use of real data set because the author used synthetic data. Limited algorithm used. He only used some few algorithms. Team to team dependency, scaled agile, and considered. So we can work through in future on this research paper, like real Zira, Azure DevOps data, velocity prediction using LSTM, multi-team dependency modeling, explainable AI for Scrum Masters. These are the some references of this paper. That's all for my part. Thank you.